So we look at B5, it says, this is a more concept question. It says excess zinc metal was added to 200 cubic centimeter of 2 molar hydrochloric acid. Write a balanced chemical equation for the reaction. So a balanced chemical equation, so that means zinc metal reacting with hydrochloric acid HCl. When these react, it produces zinc chloride. But in the process of that, you are going to find that hydrogen gas is actually going to be produced. If that is in solid, that is in aqueous, that will still be in aqueous, and that will be in gaseous form. Then we can balance it up. You can see there are 2 chlorines, 2 hydrogens, so we can put that the 2 there. Then it simply means it says balanced. All right, so remember, when a metal reacts with an acid, a salt and hydrogen gas will be produced. Then B says calculate 1, the number of moles of hydrogen gas produced in this reaction. So they want us to know the number of moles of hydrogen gas produced in this reaction. So what we are going to do, is that since they told us that zinc metal, excess zinc metal was added to, so they gave you the volume of the acid, which is 200 cubic centimeter, and they gave you the concentration, which is equal to 2 molar. So they want us to calculate the number of moles of hydrogen gas produced in this reaction. So first of all, you need to know, since this was in excess, meaning this one was limited, and hence this is called the limiting reagent. We can find the number of moles because number of moles is equal to concentration times volume. But remember, the volume, right away you get your 200 divided by 1000 to change to cubic decimeter. That will give us 0.2 cubic decimeter. So number of moles will be the concentration, which is 2 molar. 2 molar is the same as 2 mole per cubic decimeter, because mole per cubic decimeter and mole are just the same. Multiply in this case by 2. That's what we mean there, because the volume is 0.2, so the number of moles will give us 0.4 mole. Right? So now we can now compare the mole ratio from the balanced chemical equation. So according to that, how many moles of HCl? You just look at the number in front. So we have got 2 moles of HCl produces how many moles of hydrogen? What number is in front there? 1. Produces 1 mole of hydro. So you can pick up and say, what about 0.4 mole of HCl? Then how many moles of hydrogen will that give? We don't know. So x, then we cross multiply. This times that will give me 2x is equal to, this times that will be 0.4. Then I'll divide 2. I'll do it the other side. Therefore, x is equal to, that will be 0.2 mole of hydrogen. So these are the number of moles of hydrogen that would have been produced. And then it says the volume of hydrogen gas produced at RTP. Now, if you remember, 1 mole of any gas, in this case I'm talking about hydrogen, occupies a volume of 24 cubic decimeter, that is at RTP. So you just get this and say, what about 0.2 mole of hydrogen? Then what volume will that give me? So it will be, this times that is x, so it will be 0.2 multiplied by 24. And I believe when you multiply that, that will give us 4.8, and that is going to be cubic decimeter. I know maybe you are familiar, volume is equal to number of moles by 24 cubic decimeter. Yes, you can actually also use that. It's okay. So the answer will just be the same. Right, let's try to look at this question there that they gave us. It says, what mass of zinc was used in the reaction? So how do we know the mass of zinc that was used in the reaction? Well, it's very simple. So what we are going to do to find the mass of zinc that was used in this reaction, we can compare again the mole ratio of zinc to HCl. So we know that 1 mole of zinc required 2 moles of HCl. So remember, the number of moles of HCl which we calculated is 0.4, so we can say what about 0.4 more, then how many moles were required for zinc. So we cross multiply, so it will be 2x is equal to 0.4. To find x, I'll divide 2, I'll do it the other side. So x is equal to 0.2 moles of zinc. So if you know the number of moles of zinc that were needed, you can now find the mass, because mass is equal to number of moles times Mr. In this case, it's the Mr. of zinc. That's what you need to remember. Let me just try to see if I have a periodic table near me. You can actually get to use that. So mass is equal to number of moles, which is 0.2 times the Mr. of zinc. So if you go on the periodic table, the Mr. of zinc is actually 65. So it is just a matter of multiplying 0.2 multiplied by 65. Sorry, the calculator is far away from me. So 0.2 multiplied by 65, that gives you the mass is equal to 13 grams of zinc. So only 13 grams of zinc was used in the reaction there. Hopefully you got something. Please watch out as we try to do B6, and we try to look at questions under that. Watch out for that.